All right, so let's do another example problem. Let's say that we've got three charges, Q1, Q2, and Q3. Let's say that Q1 and Q2 are a distance of 35 centimeters apart. Let's say that Q1 and Q2 are a distance of 12 centimeters apart. Well, that means it's real simple math that it's going to be 23 centimeters apart for the Q2 and Q3. Okay, now I'm going to say that Q1 is equal to 14.0 microcoulombs. So I want to know what is Q2 such that there's no force on Q3. Okay, what do I mean no force? Well, Newton's second law. Okay, sum of the forces equals ma. So sum of the forces, what does sum of the forces mean? It means force 1 plus force 2. You know, if they're in opposite directions, then if that's F1 and that's F2 vector, if they're equal and opposite, then that means that F1 plus F2 equals 0. Okay, so again, back to our equilibrium stuff that we learned in physics 1. So for our problem here, Q1, Q2, Q3, we know that Q1 is 14.0 microcoulombs. So that means that if this charge is positive, it's going to be repelled. These are repelling each other. If this charge over here is also positive, it's also going to be repelling. So if these two are equal and opposite, that means the net force is 0. Okay, so that's what we want. So this force right here, that's the force on charge 3 due to charge 1. Okay, so that's going to be K sub E, Q1, Q3 over, we can call that distance, you know, R1, okay, over R1 squared. Okay, this other force over here, that's going to be the force on charge 3 due to charge 2. So that's going to be K sub E, Q2, Q3 over R2 squared. So that's going to be R2. Okay, so if these two are equal and opposite, that means that K sub E, Q1, Q3 divided by R1 squared equals K sub E, Q2, Q3 over R2 squared. Well, notice the Q3's cancel, the K sub E's cancel, so that means that Q2 is going to be equal to Q1 times R2 squared over R1 squared. Okay, so we plug in the numbers here, and that's going to be equal to Q1, which was the 14 microcoulombs, times the R2, which is 23 centimeters squared, divided by R1, 12 centimeter squared. So Q2 comes out to be 51.4 microcoulombs. Okay, now let's dissect this a little bit more. Okay, let's get a little more learning out of this. Does it matter that I did not convert these to SI units? No, because they cancel. I could have had it in inches, and that would have been fine. As long as they're both inches, they would have canceled. Not a problem. You know, you keep track of what the units are, and then that gets you past some of the problems. What if Q3, because remember we had Q1, Q2, Q3. What if Q3 were negative? What effect would that have? Well, it would mean that's attracted this way due to Q1 attracted that way due to Q2, the force of Q1, the force of Q2 still are going to be equal and opposite. They cancel. In fact, what happens if you double Q3? What happens? Well, look at the equation here. What's the equation? Q2 equals Q1 times R2 squared over R1 squared. If you change Q3, what happens? There is no Q3 in the equation. You can make Q3 anything you want, and it makes no difference. It can be positive, it can be negative, it can be huge, it can be small, it can be zero. Doesn't make any difference. If Q2 is given by this value right there, doesn't matter what Q3 is, the forces are equal and opposite, and it cancels. And that was what I asked for. What Q2 makes that happen.